When Valve announced Subtick for Counter-Strike 2, a lot of people thought this was finally going to fix the netcode. But anyone who spent time with netcode knew from day one, Subtick is not a silver bullet. And for a lot of players it actually feels worse than before. Almost everyone felt it immediately. Your spraying suddenly feels off, your grenades land differently, and sometimes you still die behind a wall even though we supposedly have this better netcode. Valve calls this an upgrade, and I think a lot of that hype created this Subtick delusion. This video is the fourth part in my netcode series. I'm going to show you what Subtick actually does, why 128 tick still feels better than 64 tick with Subtick bolted on top. And I'm gonna show you where Subtick really changes the game and where it has almost no impact at all. Welcome to the Subtick delusion. Okay, before we can even talk about the Subtick and why I think a lot of the expectations around it were unrealistic, we need to zoom out and look at what your game is already doing in a completely normal scenario. Imagine you're playing an FPS. You're walking around the map, you see an enemy, and you shoot. This looks like a very simple, very normal sequence of actions for any FPS game. Walking, aiming, shooting. But what you don't see is what's actually happening under the hood of the netcode. And if you stay with me, I promise this will all make sense. Now, looking from a very high perspective, we have the server and we have the clients. The server holds the authoritative game state and the clients are the players. From your point of view, your own movement is driven by client-side prediction. If that prediction fails, the game falls back to reconciliation to pull you back in line with the server. To render everyone else smoothly, the game uses interpolation between the past snapshots. And if there are not enough packets to interpolate, it switches to extrapolation for a short time and just guesses where players will be. When you fire your weapon, modern FPS games add server-side lag compensation on top. That means the server rewinds the game state and evaluates the shot from the shooter's point of view. Then you have hit registration itself, checking line of sight, hitboxes, and finally deciding whether that shot is valid or not. On the server side, you also have interest management or area of interest systems deciding which players and entities you even need to know about. Plus delta compression and data compression just to get all of this across the network efficiently. As you can see, there's a lot happening at the same time here, and I'm barely even scratching the surface. Now you're probably wondering, where does Subtick actually fit into this whole puzzle? Why does your spraying suddenly feel different, or why do your shots still not count? Even though this system was marketed as an improvement. Okay, so a lot of people thought, and some still think, that Subtick means instant input updates that are no longer tied to ticks. People have this delusion: I press a key and my client immediately sends that one input at the exact moment to the server. If that was true, you would flood this server in seconds. You would have thousands of packets flying around every time someone twitches their mouse. The server would be cooked. So what actually is Subtick? It's basically a timestamp attached to your input commands. Your client still sends those commands to the server once per tick, and the server still runs at 64 tick. The only thing that changed is that each command now says, I happened at this exact moment inside the tick. So the server can place your actions on a more precise timeline. And let's be honest, if Valve had announced we are adding timestamps to your inputs, people wouldn't be hyped as nearly as much as when hearing the word Subtick. Subtick sounds like something next level, like a microscopic level of precision. And since we don't have the source code, we don't even know if literally every command gets a Subtick timestamp or only a subset of actions. Now, many people were disappointed that 64 tick with Subtick doesn't feel better or at least as good as 128 tick. The reality is, it can't feel better. You are still only getting half as many updates as on a 128 tick server. There is no way to fake the missing ticks, and yes, you get more precise timing inside each tick, but the total number of updates is still much lower. A higher tick rate gives you more frequent updates. That means the game can interpolate more finely and sample your inputs more often, because your client is also sending commands more often. The higher the tick rate, the more updates you have, and the less guesswork the engine needs to do between them. What you need to understand is you are not getting a new server update for every frame you see on your monitor. These are not frame-based updates. And also, just like in life, everyone is seeing a different reality. A different pattern of packet loss will produce a differently interpolated game state. What if I exist only in your Let's not go there. I want to show you an example of what I mean. Let's imagine you have an enemy moving like this. This line represents the enemy's real movement. Now, the server sends you out only tick-based updates about his movement, his positions. All the states in between those ticks are being interpolated from your side. So, if you get only half the updates because of half the tick rate, your game will have to interpolate a lot more than with double the tick rate. And adding now a timestamp on each movement packet will not fix the problem that you are only getting half as many updates. And you use these updates as checkpoints for your interpolation. Now, the real problems start happening when on top of that you introduce packet loss. And that's when your game starts interpolating as best as it can. But you will probably see people walk paths they never been to. I mean, it's not like you will see enemies walking completely different routes. It's more like a slightly shifted or delayed movement. For example, this update never arrives at your side. That means your game will interpolate between these 2 points in a linear fashion. So you will see the enemy, instead of walking this path, you will see this. Again, a timestamp doesn't really mitigate this issue. Now you might be wondering, why don't they just crank up everything to 128 tick and call it a day? And I'm gonna talk about that, but first, let's take a look at how Subtick actually affects your actions. I'm gonna split this into two parts. Stuff that happens when you interact with other players and stuff that is only related to your own player. Okay, first let's talk about the netcode side when we interact with other players. So imagine you're walking around, at some point you see an enemy, and you both land, from each of your own perspectives, a headshot. We're going to look at this situation assuming an ideal network, no packet loss, low latency, and high FPS. So player A shoots at the beginning of the tick, and player B shoots just before the next tick. In theory, player A killed player B before he could shoot. Now, on a non-subtick server, both shots are registered at the same tick. The server still counts them as the same tick, even though A shot before B. And now, depending on the game and the rest of the netcode, the server has to decide what really happened. Now, this of course varies from game to game. When we talk about netcode, it's not always the same netcode. Two games can have completely different rules. I don't need to explain this to people playing Arc Raiders. And on a subtick server, we get this extra precision. Even though both shots are sent with the same tick update, both also contain a timestamp. So now the server can tell with more certainty who shot first and which shot should count. But listen, this is an artificial lab scenario. In reality, there are many things happening in the background. You might shoot first, but because of packet loss, your first shot packet never arrives at the server. And now B is the first one who landed a shot. Or the enemy player was being extrapolated and he was never exactly at the position you saw, so your shot doesn't count. So Subtick gives you an advantage over non-Subtick servers in these very specific timing situations. Okay, now let's talk about spraying and throwing grenades. The main thing you need to remember is this. Subtick doesn't inherently make these actions good or bad. It just makes the mechanics different from what we're used to. If you have thousands of hours in Counter-Strike on non-Subtick servers, this of course changes a lot for you because the game simply feels different. When you spray, your weapon has a specific fire rate. On servers without Subtick, your client sends these firing commands every tick. Since the fire rate doesn't line up one-to-one with the tick rate, you can imagine it will produce a specific firing pattern over time. With Subtick, your shots and the recoil effect are, technically speaking, tracked more precisely and then sent over to the server with that extra timing information. I can't draw you exactly how the shooting pattern will change, but it's very logical to assume that the pattern will be different. And that's exactly what people are reporting. For grenades or anything that involves holding and releasing a key, it's the same idea. Your press and release time now get timestamped. On non-Subtick servers, the game only registers the release on a full tick. On Subtick servers, you can effectively release at any point in between, depending of course on the decimal precision they use for the Subtick. If you're used to throwing grenades with only tick precision and then you switch to Subtick, of course it's going to feel very different. And I'm pretty sure you will not like it at first because it changes a pattern you're used to. It's muscle memory. Imagine playing a map 1,000 times, you run the same route, you throw the same grenade at exactly the same point every time. And suddenly they change the throwing precision mechanics. You're not going to like that change. It doesn't matter if it's more precise or not. People don't care that much about realism, they care if the game is fun and feels consistent. And that's the problem. If you're used to a specific motion, it will change. It will impact your game. The old tick window isn't there anymore because your key presses are sampled more precisely. Okay, now let's talk about the parts that have nothing to do with the Subtick at all, but people still credit Subtick for them. Before we continue, a quick word from today's sponsor, Brilliant. If technical interviews have successfully convinced you that you don't understand anything anymore, how about you try out something different? Brilliant lets you interact with math, data, and computer science problems instead of just watching someone else explain them. It's hands-on, so you end up learning by doing. I use it when I catch myself rewriting the same code for the 5th time this week, or when I want to remind my brain it's capable of something other than attending meetings. Brilliant takes you from the basics and builds up slowly. So even if your brain currently operates in 15-minute chunks, you can still sit down and do a few puzzles. It's the educational equivalent of turning your brain off and on again. To learn for free on Brilliant, go to brilliant.org/Tariq10x, scan the QR code on screen, or click on the link in the description. Brilliant's also giving my viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Now, a lot of people have been uploading videos where they clearly aim at someone, shoot, and the shot doesn't register at all. So the first thought is, okay, Valve introduced Subtick, and ever since then online multiplayer sucks, so it has to be the Subtick. And that might be true to some degree, but it's oversimplifying the problem, and in most these cases, it's just not true. So when you fire a shot, the game doesn't brute force check your bullet against every entity in the game on every tick. It first narrows down the set of entities to a smaller group you could potentially see or hit. In older games like Quake, this was called PVS, potentially visible set. Nowadays people call it area of interest or interest management. So the game goes from maybe 100 entities in the match down to, let's say, 20 that you can actually see from your current position on the map. On top of that, because of server-side lag compensation, the server has to rewind the game state to the moment you fired and check if you could see the enemy at that time. If at that moment the server decides for whatever reason that this enemy is not inside your area of interest, your shot will simply not count. If there is a bug in the netcode or in the map processing, you can end up in a situation where you see the enemy on your screen, but the server thinks you can't see them or you can't shoot them. And that has nothing to do with the Subtick. Also, the server is not sending you a full, complete game state with all entities on every tick. It sends you delta compressed snapshots. That means you only get the changes since the last snapshot you received. If something hasn't moved since last tick, the server will not send it. If the server messes up this snapshot logic, you might not get correct updates even though the entity is still there. Again, this is nothing to do with the subtick. And I've talked about this in detail in my Quake 3 netcode analysis video. I even go through the source code there because Quake 3 has been open sourced for something like 20 years now. Of course, things have improved since then, things have changed, but the basic building blocks, the fundamentals are still the same. And now if you're wondering, why is the netcode doing all this interest management, delta compression, data compression? It's because you don't have an infinite amount of processing power and infinite bandwidth. You have to reduce the amount of data as much as possible, especially in modern games with more complex physics and more stuff going on. For complex games like Counter-Strike, sending full brute force updates for everything would need a huge amount of processing power, on top of everything else the server is already doing. Okay, so that was one area where things can go wrong if you mess the netcode up. The second part is dealing with packet loss and high latency. You have to understand that packets will get lost. That's just how networks operate. The goal of good netcode is to hide that from the player as much as possible. The game has to keep running for a short window of time while it waits for the next snapshot, so your experience still feels stable and responsive. The game is trying to give you the impression that everything is running smoothly. Under my last video, a lot of people commented that in games like Ark Raiders or Battlefield 6, they see exactly these issues. They shoot at someone and the shot doesn't count, or they hide behind a wall and still die. Most of that is down to high latency and packet loss, and especially how much packet loss and latency the game allows before it finally says enough. Now, another thing is, to make the game feel fair from the shooter's perspective, you need server-side lag compensation. But to make it fair for everyone else, you have to limit that window. And that's where you get people abusing lag switches. Before they swing a corner, they flip on the lag switch, spike their latency up, abuse peeker's advantage, and smoke anyone who just wanted to relax on a Friday evening. Again, Subtick cannot help you in any of these situations. It's just a timestamp. It has a limited effect on the whole netcode and the game experience. I mean, I'm glad that people are still trying to come up with new ideas in the netcode. But we should be real with ourselves and we should focus on tuning the fundamentals first, like writing optimized code. And maybe, just maybe, invest more money into more and better servers. How about that? Conclusion. We could end the video with one sentence. Tick rate is tick rate, and you can't really dance your way around it. And I know a lot of you are thinking, okay, then why don't they just crank it up to 128? If I had to guess, I would say the main reason is profit. Running high-performance servers all over the world with low latency and high bandwidth is a lot more expensive than running servers at half the tick rate. They probably did some data science on this and said something like, if we keep it at 64 tick, we'll lose maybe 5% of the players, but we save 20% on the server costs, and overall that's still a net positive for the business. I'm making these numbers up, obviously, but you get my point. Fact is, online gaming is a business. That's why almost every game now has in-game purchases for every possible thing. You want a red knife? Pay me. You don't want to grind? Pay me. And I don't even want to start with the gambling aspect of it, where we have kids that are 12 years old opening loot boxes with your mom's credit card. Whoever invented this, shame on you. Some people also commented on my last video saying that netcode used to be better in older games. You have to understand, those games were sending a tiny fraction of the data modern games send. And back then, people wrote much more optimized code. They cared about squeezing every bit of performance out. They cared more about the gaming experience. Today, it often feels like they start with how do we pull as much cash as possible out of the players, and only after that they start thinking about the actual game. And I don't even think that's a crazy take. And this is the point where I want to take a step back from the technical side for a second. Now listen. Back in the day, most games didn't have rankings. You didn't care that much about your score. You were just playing for fun. I can tell you from my own experience, when we were playing Dota 1, it was about having fun with friends. But when we switched to Dota 2 and they introduced MMR, the ranking system, everything changed. Suddenly, everyone was tryharding every game. It went from let's have fun to people not wanting to play together because they blamed each other for losing 25 MMR points. So honestly, the only real solution is this. If a game is making you more miserable than happy, if it's a net negative in your life, just stop playing, brother. I used to play Dota for 10 or 12 hours a day, and one day I just woke up and decided to stop. I told all my friends I'm not coming to play anymore, and that was it. After a few weeks, I didn't even think about Dota anymore. Then I would log in maybe twice a year during holidays, play a game or two, and every time I felt like it got even more toxic. And that just confirmed that my decision was right. So, if online games with a crappy netcode have a negative impact on your mental health, brother, just stop playing. It's not worth your energy. Trust me. I want to take the moment and say a big thank you to my Patreons and YouTube members and anyone who has been supporting me since day one. If you want to support the channel, there's a Patreon link in the description. You can also become a YouTube member or leave me a comment. Comments really seem to help the algorithm push my videos. Okay, so that's it for today. If you liked the video, hit like and subscribe, and see you in the next one. Tariq 10x.